Hello students, myself Ashish Rajwade. I am working as a physics faculty in World. In 2021 JEE mains, our one student has scored 98.02 percentile, and in which physics contribution is 98.7 percentile. So in this session we are going to discuss the test solution of the chapter current electricity. So now I am starting the discussion. The first question in the test was a wire of resistance 4 ohm is stretched to twice its original length. The resistance of stretched wire is. Now listen here. The original resistance of the wire is 4 ohm and it is stretched to twice its original length. Then the resistance of the stretched wire is. So new resistance R dash is equal to N square times R. Okay. So in that case it is 2 square into 4, which is 16, because R is equal to rho L by A. Okay. So when volume remain constant, so in that case what happens? V volume is equal to area into length. So R is equal to rho L by A. So if we try to arrange it for A, so it becomes L square. So that's why N square I have written here. So that's why it is N square. So 2 square into 4, that is 16 ohm. So option D is the answer for this question. R is equal to rho L by A, and you have to arrange volume is equal to area into length. So area is volume upon length. So that L and L multiplying, it is L square. So it is N square. And twice, so length is doubled. So that's why it is 2 square, so it is 16 ohm. Option D is the answer. Then question number 2. With the rise of temperature, the resistivity of semiconductor is. Now in case of semiconductor, as we are aware that as temperature increases, its resistivity decreases and its conductivity increases. So option C is the answer for this question. As temperature increases, resistivity decreases. Then question number 3. Two resistances are joined in parallel whose equivalent resistance is 3 by 5 ohm. One of the resistance wire is broken and effective resistance becomes 3 ohm. The resistance of the wire that got broken what? Now listen here. Question number 3 says two resistance wires are joined in parallel, then its equivalent resistance. So equivalent resistance R is equal to R1 R2 upon R1 plus R2 is equal to 3 by 5. And one of the resistance wire is broken and the effective resistance becomes 3 ohms. So now R1 is 3 ohms. So R2 is 3 by 4 ohms. So that's why answer for this question is option D. So you have been given R1 R2 by R1 plus R2, which is 3 by 5, in which R1 is 3. So R2 is 3 by 4. So option D. Question number 3. It is a simply series parallel combination of resistance. Question number 4. The equivalent resistance of resistors connected in series 6 ohm and parallel equivalent resistance is 4 by 3 ohm. What are the values of resistance? Again, in case of question number 4, they are saying R1 plus R2 is equal R1 plus the resistances are joined in parallel whose equivalent resistance in case of equivalent resistance when they are connected in series is 6 ohm. Okay, so R1 plus R2 is equal to 6 ohm. And their parallel combination R1 R2 by R1 plus R2 is 4 by 3. So if you solve this, you are getting C as the answer for this question, that is 4 and 2. In such type of questions, by using the options also you can find out the answer. Because in option number C, if you observe 4 and 2, now series combination of 4 and 2 becomes 6. And if you make them parallel, then 4 into 2, 8 by 6. Okay, that is 4 by 3. So this is matching with the given conditions. That's the option C is the answer. Okay, so by making the use of options also you can mark the answer. Question number 5. In question number 5, there is a diagram, and in that diagram if you observe 75 ohm and 50 ohm are parallel, and again this combination is parallel with 50 ohm. So 1 upon R equivalent is 1 upon 50 plus 1 upon 75 plus 1 upon 50. If you solve this, it is 75 by 4, and that 100 ohm resistance is series with it. So 100 plus 75 by 4. So that overall resistance is 118.75 ohm. So it is 118.75 ohm. Option C is the answer for question number 5. Now question number 6. Three resistances 2 ohm, 3 ohm and 4 ohm are connected in parallel. The ratio of their currents passing through when a potential difference is applied across end will be. Now these resistances are connected in parallel. So you know that in parallel combination of resistances, potential difference remains constant. So V is equal to IR. So I is inversely proportional to R now. So I1 has to I2 has to I3 is equal to 1 upon R1 has to 1 upon R2 has to 1 upon R3, which is 1 by 2 has to 1 by 3 has to 1 by 4. If you take LCM, you are getting 6 has to 4 has to 3, which is option D is the answer for the question number 6. Now question number 7. Question number 7 is the electric current flowing through 4 ohm and 6 ohm resistance is respectively. Now there is a diagram, and in that diagram you have to find out the current. Now 4 ohm and 6 ohm. Now resistance is actually we have to find out the current. So first we will find out the equivalent resistance. So that 4 and 4 they are parallel, and 6 and 6. So whenever two same value resistances are in parallel, then equivalent resistance becomes half. So 4 and 4 parallel means it is giving 2, and 6 and 6 means it is giving 3. This 3 and 2 are again connected in series, which becomes 5. So 20 by 5 is 4 ampere. So answer for the question number 7 is D, 4 ampere. Then question number 8. We have a galvanometer of resistance 25 ohm. If it is shunted by a 2.5 ohm wire, the part of total current that flows into galvanometer. It means you know that in galvanometer there is a shunt resistance is connected in parallel with it to divert the extra current that I already discussed with you. So in question number 8, Ig, current flowing through galvanometer, is equal to overall current into shunt resistance upon galvanometer resistance plus shunt resistance. So Ig upon I is equal to 2.5 shunt resistance upon 2.5 shunt plus galvanometer 25, which gives me 2.5 by 27.5, which is 1 by 11. As you know that shunt resistance is very much less than the galvanometer resistance in case of ammeter. That's why answer is 1 by 11. Option D is the answer for the question number 8. Now question number 9. A voltmeter has a resistance of G ohm and a range V volt. The value of resistance that is used in series to convert it into the voltmeter of range nanovolt is. Now listen here. N volt is. Sorry. Now listen here. Simply series resistance of voltmeter is what? Rs is V by Ig minus G. So if V is equal to N times Vg. If V is equal to N times Vg. So N times Vg by Ig minus G. But Vg by Ig is nothing but G. So Ng minus G, take G common. So Rs is G into bracket N minus 1. So basically this question tells us how to extend the range of voltmeter. It means how to increase the measuring capacity of the voltmeter. G into N minus 1. So this N indicates how much full scale deflection voltage is Vg, and actual measure, the voltage we want to measure is V. Then by what factor that voltage is more greater, that N is the multiplication factor. So option C is the answer for the question number 9. Question number 10. In an ammeter, 4% of the main current is passing through the galvanometer. If shunt resistance is 5 ohm, then resistance of galvanometer will be. Now listen here. In question number 10, shunt resistance is Ig upon I minus Ig into G. Now 4%, so it is 4 by 100 times I into G equal to 4 by 96G upon I minus 4 by 100 into I. It means Ig is 4%, that's why it is 4 by 100. So if you solve this for G, you are getting it in 96 by 4 into 5, which is 120 ohm. So galvanometer resistance is here to 120 ohm. In the previous problem, there is S also given, galvanometer resistance is also given. In this problem, G is asked. So option C is the answer for question number 10. Now question number 11. Question number 11, once again, it is a question based on galvanometer. A galvanometer has a resistance of 3663 ohm. A shunt S is connected across it such that 1 by 34 of the total current passes through galvanometer. The value of shunt is. Now listen here. In question number 11, Ig upon I is equal to S upon S plus G, which is equal to 1 upon 34. Ig upon I. So S is equal to G upon 33. But G is what? G is 3663 upon 33, which is 11 ohms. So for question number 11, option B is the answer, because Ig is equal to I into S upon S plus G, and I upon I is given, it is 1 by 34. Clear? So this is the solution for question number 11. So basically from question 8 to question 11, these are the questions based on galvanometer, how to convert your galvanometer into ammeter and volt. Now question number 12 is, a voltmeter has resistance of 2000 ohm and it can measure up to 2 volt. If we want to increase its range by 8 volt, then required resistance in series is. Now listen here, we know that R is equal to V by Ig minus G, but we want, in the problem they have asked, it can measure up to 2 volt. If we want to increase its range by 8 volt, it means 8 plus 2, 10 volt now overall voltage. So that's why R is equal to V by Ig minus G. So 10 by Ig is 1 by 1000, because Ig is equal to 2 by 2000, which is 1 by 1000. So final minus 2000, because it is a G. So final answer is 8 kilo ohm or 8000 ohms. So definitely in case of voltmeter you will find series resistance in kilo ohm. It is very high value resistance. But in case of ammeter, it is very low value resistance. Then option D is the answer. Then question number 13 is, a galvanometer of resistance 15 ohm gives full scale deflection for the current of 2 milliampere. Calculate the shunt resistance needed to convert it into the ammeter of range 0 to 5 ampere. Now galvanometer resistance is 12 ohm, 15 ohm. Ig, full scale deflection current 2 milliampere, and current to be measured is 5 ampere. So S is Ig upon I minus Ig into G. Ig is 2 into 10 raised to minus 3 into G 15 upon 3 into 10 raised to minus 3. Okay, that is I minus Ig. So 5 minus 2 is 3 milliampere. So S is 0.006 ohm or 6 milli ohm. So in the previous problem, if you observe, series resistance was 8 kilo ohm. Here it is 6 milli ohm. So in case of ammeter, you will always find the shunt resistance is in milli ohm or very low value. But in case of voltmeter, it is high value resistance. So option D is the correct answer for this question number 13. Question number 14. A moving coil galvanometer has a resistance of 25 ohm and gives full scale deflection for 10 milliampere. How will you convert it into the voltmeter ranges from 0 to 100 volt? So again, R is equal to V by Ig minus G. V is 100 upon Ig 10 raised to minus 2 minus G 25, which gives me 9915, that is 9.915 kilo ohm resistance. Again option A, that is option A is for 13 is 0. This is actually question number 4. In case of 14, 9.97 or 9.915 approximately, because and it is always in series, because in our options they are always they are given in parallel also. So in case of voltmeter, we want to connect the resistance in series. It should not be parallel. So option A is the correct answer for the question number 14. Now question number 15. In the circuit shown below, the total resistance between A and B is. So if you observe carefully that particular circuit, then you find that 1 upon R equivalent is equal to 1 upon R plus 1 upon 2R plus 1 upon 2R. It means what actually? These three resistances are in parallel. If you try to observe this, then R, 2R and 2R are always connected in parallel. That's why overall resistance is equal to R by 2. So that arrangement is different, but that three resistances are in parallel combination. Okay, so in parallel means end-to-end connection. That's why answer is R by 2, option C. Then 16 number question. A wire has a resistance of 6 ohm. It is cut into two parts. Both half values are connected in parallel. New resistance is. We know that R is rho L by. So if we cut a wire into two equal half, then overall resistance also half R by 2. Now if we are connected in parallel, so what happens in that case? Net resistance is equal to what? 1.5 ohm, because basically the wire has resistance of 6 ohm. So definitely we are connecting them in parallel. So that's why each part is now 1.5. So that's why 1.5 into 4, I am getting it as 6 ohm. Okay, so option D is the correct answer for this question number 16. Now 17 question is based on the EMF of the cell. four cells, each of EMFE and internal resistance R are connected in series across the external resistance capital R. By mistake, one of the cell is connected in reverse, then the current in the external circuit. Now listen here. Whenever a cell is connected in, multiple cells are connected in series, and if one of the cell is by mistake it is polarity is reverse, then I already explained you, both the cells will nullify each other. So definitely we have to take 3E minus E, which is 2E. So current I is equal to 2E upon 4R plus R. So option A is the correct answer for this question. Definitely that's because there are 4 cells. So 4 cells, it means 4E total series combination EMF. But when one cell is reverse, then definitely it also nullify the other cell. So it means we have to eliminate the contribution of 2 cells. It means we have to deduct 2E from 4E. So resultant is now 2E. That's why here 2E. So if there are 6 cells and one cell is reversed, then 4E. So answer that time answer becomes 4E by 4R plus R. This 4R is series internal resistance and R is external. That's why option A is the correct answer. So whenever the polarity of the one cell is reversed, then you nullify the effect of both 2 cells for one reversal of polarity. Okay. So option A is the correct answer for the question number 17. Then question number 18. Question number 18 is for driving a current of 2 ampere for 6 minutes in a circuit, 1000 joule of work is to be done. The EMF of the source is. Now listen here. In 18, Q is equal to I into T. So that's why Q is equal to 720 coulombs. Now V is W by Q. W is 1000 joule upon 720. It gives me 1.38 volt. That's why in the problem they have given time and current. So in that case, the option A is the correct answer, 1.38. So simply potential is equal to work done per unit charge. But charge is directly not given. In that problem, they have given current and time. But the time is also in minute. So converted into seconds. That's why it is how much? It is 2 ampere for 6 minutes. So that's why 2 into 6 into 60. First calculate charge in coulomb, 720 coulomb. Then given work is 1000 joules. 1000 joules by 720 will give me 1.38 volt. So option A is the correct answer for this question. Then question number 19. A battery of EMF 10 volt and internal resistance 3 ohm is connected to a resistor. The current in the circuit is 0.5 ampere. The terminal voltage, again listen, terminal voltage V is equal to E minus IR. If cell is giving the energy, if cell is in discharging mode, that I already explained you. So now in this case EMF is 10 minus current is how much current 0.5 ampere into internal resistance 3 ohm, that will give me 8.5 volt, option D. So definitely terminal voltage is always less than the EMF of the cell if the cell is in discharging mode. So you have to select the answer which is always less than 10. So option A is not the correct answer. Option B is also not correct answer, 0. And option C 1.5. Now 1.5 is too much less than 10 volt. Okay, because internal resistance is very negligible. So if the EMF is 10 volt, then 1 to 2 volt less than the 10. It is a terminal voltage. So definitely answer is option D. So even if you not calculate the such type of question, solution for such type of question, you can easily tick mark the answer. Okay, so that's why option D is the. Now question number 20 is. In the question number 20, they are asking us the circuit shown below, the current I1 and I2 are. So in the question number 20, first we have to calculate that 12 and 4 are in parallel, which gives me 12 into 4 by 12 plus 4, which is 3, and 2 ohm resistance is series, so it is 5 ohm. So I is equal to E upon R plus R. E is 12 upon R plus R means 5 ohm capital R, and small r is 1 ohm internal resistance, which is 6, so it is 2 ampere. Now I1 plus I2 is equal to 2 ampere. So I1 is equal to, as per current division formula, R2 upon R1 plus R2 into total I. So R2 is 4, total resistance 12 plus 4 16 into I is 2, it is 0.5 ampere. So I1 is 0.5 ampere. So I2 is how much? 2 minus 0.5, which is 1.5 ampere. So option B is the correct answer for the question number 20. Here simply we have to use series parallel combination as well as current division rule. Now in 21 question number is what? In Wistone network, P is equal to 2 ohm, Q is equal to 2 ohm, and R is equal to 2 ohm, S is equal to 3 ohm. The resistance which is to be shunted in order to bridge, in order to make the bridge balance. Now listen here, this P by Q is equal to R by S. So 2 by 2 is equal to 2 by this particular S dash. But this S dash, new resistance, is nothing but parallel with unknown resistance X. So S into X by that is S into X by S plus X. So that's why X is equal to 6 ohm. So 6 ohm resistance has to be connected in parallel to make the bridge balance. So option in this particular question, question number 21, option C is the correct answer for this question. Now such questions can be handled with the help of option. You want to add another unknown resistance in parallel with given resistance. So take one each option, and after using that option, if that bridge is balanced for that particular option, then this is the answer for that question. Then question number 22. 22 is 4 resistances are connected as shown in the figure. The equivalent resistance between P and Q is. Now listen here, A by B is equal to C by D is equal to 1.5. Now listen here, lower arm resistance is 5 ohm and upper arm resistance is 5 ohm because 3 and 2 are in series. Lower arm resistance is what? 4 plus 6, 10 ohm. So R equivalent is 5 into 10 upon 15 is equal to 10 by 3, because upper arm 5, overall resistance 5, lower arm 10. Now the 5 and 10 are in parallel, which gives me equivalent 10 by 3. Option A is the correct answer for this question, 10 by 3. Now 23 question. 23 number, the amount of charge Q passes in time t through a cross section of wire Q is 5t square plus 3t plus 1. Value of current at time t equal to 5 seconds each. Now listen, I is dq by dt. D by dt of Q is 5t square plus 3t plus 1. So if you differentiate it, you are getting 10t plus 3, that is 53 ampere. It is a time dependent, charge is given, you have to calculate the current. Option C is the correct answer. Then 24, you have to calculate in 24, a 10 meter long wire of resistance 20 ohm is connected in series with the battery of EMF 3 volt and resistance of 10 ohm. Find the potential gradient along the wire. Now listen here, potential gradient K is VAB by L, which is I into RAB by L. Now I is E by R plus small r into RAB by L. If you substitute all the values, L is 10, then R is 20, RAB is 20, L is 10. Okay, then basically EMF is 3 volt, you are getting 0.2 volt per meter. So option B is the correct answer. Simply you have to write K is VAB by L. Then 25 number question. The resistance of wire is R ohm. The wire is stretched to double its length, keeping volume constant. Now the resistance of the wire becomes. Now listen here. R is rho L by, but you know that volume is area into length. But so area is volume upon length, which gives me R is rho L square by V. It means R is proportional to L square. So R1 by R2 is L1 by L2 whole square. So R2 is equal to 4 ohm. So option A is the correct answer for question number 25. Now question number 26. A wire of length L is drawn such that its diameter is reduced to half of its original diameter. If initial resistance of the wire is 10 ohm, then the resistance would be. Now listen here. In 26, volume is equal to pi r square L. So R is d by 2. So it is pi d square L by 4. New volume is pi d square by 16 L dash. So from these two, you are getting new length is 4 times of original length. That's why R dash is equal to 16 into 4 rho L by pi d square. It means resistance becomes 16 times the original resistance, which is 160 ohm, because original resistance was 10. 16 into 10, 160 ohm. So 26 option A, 160 ohm is the correct answer for this question. Again 27 question is based on charge. A current flowing through wire depend on the time as R is equal to 10 plus 4 into T. The charge crossing through the section of the wire in 10 seconds each. Now listen, dq is equal to I into dt. So q is equal to integration of I means 10 plus 40 into dt. Limits 0 to 10. If you solve this, you are getting q is 300 coulomb. So option B, 300 coulomb is the correct answer for this question. Simply I is equal to dq by dt. Now 28. 28 number question. Two batteries A and B whose EMF is 2 volt are connected in series with the external resistance capital R of 1 ohm. internal resistance of the battery A is 1.9 ohm and that of B is 0.9 ohm, the potential difference across the battery is. Now listen here. Total resistance is what? 1.9 plus 0.9 plus 1, which is 3.8, and total EMF is what? 4 volt. So terminal voltage is E minus IR. E is 2 minus 4. Now listen here. This is IR, internal resistance is 1.9, and R is E by R. So 4 by total resistance 3.8. So this EMF minus I into R. This is the internal resistance, and I is 4 upon 3.8. This EMF 4 upon total resistance 3.8 into internal resistance 1.9, which gives me answer as 0. So terminal potential difference is equal to 0. Okay, because in this case E is equal to IR. It means EMF is equal to the drop across the internal resistance. That's why you are getting 0 terminal potential difference. Okay, so option C is the correct answer for this question, and this question number 28 is based on the discharging of the cell. Clear? Question number 29 is the internal resistance of a 2.1 volt cell which gives a current of 0.2 ampere through a resistance of 10 ohm is. Now listen here. 29. E is equal to I into bracket external resistance plus internal resistance, 2.11 EMF, then I is 0.2, external R, so internal resistance is 0.5. So simply this is E is equal to I into bracket capital R plus small r, where small r is internal resistance. Option B 0.5 is the answer for the question number 29. Question number 30. The resistances in left and right gap of meter bridge are 20 and 30. When the resistance in left gap is reduced to half, the balance point shift by. Now listen here. As per the meter bridge, P by Q is L by 100 minus L, which is 20 by 30, because 20 it is a what we can say resistance P is 20 and Q is 30. Now L, after solving this, you are getting L is 40. So now if P is becomes now resistance length of P, now this is 40, and in the problem they are asking us when the resistance in the left gap is reduced to half, now left gap resistance becomes 10. So now 10 by 30 is L dash by 100 minus L dash, so new length becomes 25. So in this case what happens, original balancing point was 40 centimeter from the left, now balancing point is 25 centimeter from the left. It means the balancing point is shifted by how much? 40 minus 25 means 15 centimeter to the left. The balancing point is shifted. So 15 centimeter to the left. Option B is the correct answer for this question. Again listen here. P by Q is L by 100 minus L, which is 20 by 30. So now balancing length is 40 centimeter from the left. Now resistance is reduces to half, it is 10. So now 10 by 30 is L dash by 100 minus L dash. So now new balancing length becomes 25. So original balancing length was 40, now it becomes 25. So shift is 15, but it is to the left. So option B is the answer for this question number 30. Now question number 31. Voltmeter of range 3 volt and resistance 200 ohm cannot be ammeter of range. Now listen, current full scale deflection current is what? V by 3 by 200, because it is V by Ig. That is 0.015, which is 15 milliampere. So it cannot be the ammeter of 15. It means for 31 number question, if you observe this, then it should not exceed 15 milliampere. So in option, if you observe, both A and B are the correct option, because in correct option 1 it is 10 milliampere. It is in option A it is 10 milliampere, but in option B it is 100 milliampere. So it should not exceed the how much? 15 milliampere. So this 100 milliampere is greater than 15. So option A is the correct answer, because 10 milliampere only. It is less than 15 milliampere. Then option A is the correct answer for 31. Then 32. Electromotive force is the force which is able to maintain the current, which is able to maintain a constant potential difference. Because electromotive force actually means what? Whenever the cell is in open circuited condition, that time it is called EMF. If you connect the load, that time you measure the terminal potential difference. So it should be the potential difference. This is this question is related with the cell theoretical aspect. Okay, so potential, to maintain the constant potential difference. Then question number 33, again it is based on potential gradient. A current of 0.01 milliampere passes through the potentiometer wire of resistivity 10⁻⁹ ohm centimeter and area of cross section 10⁻⁻² centimeter square. The potential gradient is. Now listen here, potential gradient K is what V by L, but V is I into R by L, but R is rho L by A, so R is I into rho L by A into L, which is I rho by A. Substitute I, rho and area, you are getting K is 10⁸ volt per meter. So simply potential gradient is what? I R by L. Why? Because VAB is the potential difference, which is I into R upon L. So R is rho L by A, which is I rho upon A. So option number D is the correct answer for the question number 33. Now question number 34. Two wires of same material have length L and 2L and cross sectional area A 4A and A, the ratio of their specific resistance. Now listen, a specific resistance means resistivity. Resistivity is not dependent on length and area, it is dependent on material. Now two wires of same material, so definitely their specific resistances are also same. It means answer is 1:1. Option D is the correct answer. Because specific resistance or resistivity is material dependent, it does not dependent on area and length. So even though in the problem length is changed, area is changed, but ratio of their resistivity remains same. So option D is the correct answer. And finally last question, what is the magnitude of current I in the circuit? There is a one circuit is given, as you know, in the form of delta network. And what is the magnitude of current? If you observe that 30 and 60, now listen, this 30 ohm and resistance between A and C and B and C, they are in series. So definitely 30 plus 30, 60, and that 60 and 30 are in parallel. Now how do I identify whether the resistances are series or parallel? Current, if the current flowing in AC branch is same as that of BC branch, then that two resistances are in series. So definitely same current. So that's why 60 into 30 upon 30 plus 60, which is 1800 upon 90, which gives me 20 ohm as the overall resistance, and I is equal to 2 by 20 because 2 volt battery is connected, so which is 1 by 10.1 ampere. So option D is the correct answer for the question number 35. Okay, so in this way we have completed all the 35 questions from the test. And basically this current electricity chapter is very important, and you have to focus from 11 portion, you have to focus on, that is specific resistance. It means R is equal to rho L by A formula. Okay, then temperature dependence of resistance, then batteries and cells because electromotive force. These three important topics that you have to focus in case of this 11 portion. And in 12th portion, if you have to focus on the meter bridge, then potential gradient. These are the two, or potentiometer. These two are the important. It means total 5 subtopics are important in case of this chapter, current electricity. Thank you.
ये बिंदास है बंदा, 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 ये बिंदास है। रस पीने की प्यास है